Assalamu alaikum everyone, this is Shoheb and welcome to Make It. And this is the very much first project of this page, and which is tachometer using IR sensor. So why I am saying this using IR sensor, because this IR sensor module is the main component of this whole project. So first of all, obviously we have to take the knowledge about this module, obviously. So to operate this module, you have 3 pins, and you have to give power and take the output signal through these pins. It's like it has VCC, ground and output pin. Through this VCC pin and this ground, you have to give power to this module. Right, you can give either 5 volt or 3.3 volt from Arduino or any types of microcontroller, and so this output pin, this module keeps signal to the microcontroller, which is further processed to give the actual desired result or what you want. And in this module we can see two similar things like LED, but these two things are not LEDs. One is the emitter or the transmitter of IR signal, and another one is the receiver, which is this black one. Okay, and how it and what is this? This is something like potentiometer. Okay, this actually limits the distance of the operation of this module. So how these things actually works, like uh, basically we use this module to detect n types of obstacles. Okay, so for this reason, first of all, this emitter emits the IR signal, and IR signal is emitted like this one. If this IR signal is encountered by any types of object or obstacles, this IR signal is bounced back to this IR receiver like this one. Okay, so if there is no obstacle, then the IR signal won't be bounced back to this receiver. So if there is not any types of obstacle, then always this output pin keeps the high result, high analog signal, analog read, like 124 1024. Okay, and if any types of obstacle is detected, then this rating is less than 100 or 200 or even 50. Okay, so by just manipulating these types of things, you can make any types of projects, or you can just take this module into your work. Hopefully you have a simple idea about this module. So going to the next step in next page. Okay, this is the connection diagram. Simply what project I have made, the connection diagram I have given like this one. So I am not telling you one by one. You see this connection diagram in the PDF and just make the connection like as it is I have made. Okay, so you can change the connection diagram, but you have to change the code a little bit. And additionally, I have to say one thing, that is I have used this OLED display to see the RPM reading, and this is an Arduino Uno, and this is the IR sensor, and these all things are the connections. In the next page, this is the main part where I'll try to talk about how those things, the whole project is working. Okay, this is the working principle, right? So I have implemented two theories here in one project, which is one, calculate RPM by measuring time between two cards, and the formula is this one. And I am using this method is for the lower RPM reading, right? And for the higher RPM reading, I have used this method, which is cut numbers. I mean, measuring cut numbers for 5 seconds and get per second cut, and then get per minute cut by multiplying with 60. So first of all, we talk about this first one. What is it? Calculate RPM. I mean, actually it calculates the time between two curves. Like how these things work. this is the IR sensor, suppose, and then it is a fan which has only one blade. So at T1 it gets one cut, okay, and then it keeps getting the time, okay. It will wait. As soon as a next cut is happens, it takes that time, okay. That means one revolution only is completed. So the time is between these two cut is T2 minus T1. That means in this time one revolution is completed, okay. So how much revolution will be completed in 60 seconds, okay, in per minute, in a minute, right? So this is the calculation of the RPM simply. So you can calculate the things like 1 divided by delta T multiplied with 60, which is very much simple, okay. But the problem arises with things with this first thing is that when the RPM gets higher, like up to 500, 600,000, then the this IR sensor reading or the calculation of the microcontroller, it takes a little bit time, and for this taking of the time, we it it, it gives error to the reading, so we can get the actual reading. So I have solved this problem with this second number theory. How this second number theory works, I'm telling you now. Wait a minute. So here we can say that measure cut numbers for 5 seconds and get per second cut, then get per minute cut by multiplying 60. So uh, you have to measure the number of cuts of the blade of a fan for 5 seconds, okay. Like here time is counted, one cut is completed, second cut is completed, third cut is completed, like this one, okay. Then suppose you have 6 cuts, okay, which is for 5 seconds. That means per second cut is 6 by 5, okay. Then if we multiply this per second cut with 60, then I can get the per minute cut, and per minute cut means per minute revolutions, okay. So this is the simple tricks, but there is also a problem with this method, because you know what I am making here, I am taking that the per cut calculation will be one revolution. That means it will start counting as soon as it just passing this IR sensor. That means when it will come here, one cut means one revolutions, right? But sometimes it works like this. First cut is happen here, the next cut that means like first cut will be counted here, or the blade could be here, or the blade could be here. So the position is not fixed of the blade at any point, okay. In my theory, in my project, I am taking that the initial position is here. So when one cut happens, that means one revolution. But it's actually not in practical. The blade could be here, there, or could be there anywhere. So there could be the error of this reading. So, but one important thing is that, or one relieving point is that, when we go to the higher types, higher reading, higher RPM reading, like more than 100,000, 500, 600, 700, then this error actually doesn't matter. You can get particularly approximately a result or an idea at which RPM range the rotating object is rotating. So you can neglect these types of error, okay. So hopefully you can understand how these things actually working in this project, okay. So in the next page we can see that there is some experimental data. That means I have taken an original IR sensor for calibrating my this die project, okay. So where this original original IR sensor is giving these readings, and my die, that means what I have made. Die means DIY, do it yourself, giving these RPM readings. So you can see with these two values are very much close. That means the original one is giving 1082 RPM, my one is given 1076. Okay, like original one is giving 668.3, my one is giving 668. So these things are very much close. Okay, so here the real image of my project, you can see that I have used this IR sensor here, the OLED display here, and at the back side I have just attached this Arduino Uno. Okay. I could not fix this Arduino Uno at that part, but at the opposite side I have fixed this one like this. Okay, so this is the code, but before talking about this code I will try to show you the real video of this real project. In this video I will show you how the reading is taken and how the similarities between the two readings is. So you can see that the real tachometer is giving a reading of 2017. Okay, so my one is giving 2016. So I think that the two reading is very much close. That means there is a very much low error, right? So let's take another video. So in this video, the RPM meter is giving 178.6 RPM reading. My one is giving 180. So I can say that these two values are very much similar and there is a very much low error. And in the next I will show you another video of this reading, that the tachometer, the real tachometer is giving a reading which is close to 2000. Okay, but one thing I have to tell you, that this tachometer is measuring the speed of this fan which has 3 blades. So to get the real RPM, the accurate RPM, you have to divide this 2000 by 3. Okay, so if you divide this 2000 by 3, you get a number which is very much close to 656 or 660. That's it. So you can see that the both real RPM meter, I mean real tachometer, and my die tachometer is giving very much similar reading. So you can say that this is very much close. Okay, these things are very much close. So moving back to the PDF, move back to this PDF sections, and now I will try to tell something about this code sections. So this is the code. Okay, you don't have to take any types of tension about this code, because I will upload the whole code to the attached file with this video. But something I have to tell you, that in this code you can see that there is the one part I am just I have given that constant int blade. This part is about the blade number of that particular fan. Okay, so you can directly use this die tachometer to any types of fan. Before using this project, you have to mention how much blade that particular fan has. Suppose if the fan has 3 blades, you have to mention 3 here. If the fan has 2 blades, then you have to mention 2 here. This is the simple one. And it has also some pin numbers here, you have to mention according to yourself. Okay, and if you I can tell you the meaning of the code, but you know the video will be large and it won't be appropriate. But one simple idea is that you can copy all the codes and put these things into ChatGPT or Microsoft Copilot or whatever you want, or any types of AI chat box. The AI will give you all the meaning of this code. And one things you have to see that I have used something like ladder. Okay, it has a ladder sections. So how this things actually works, you know, in this whole project there also have some disadvantage. Okay, like when the tachometer takes the reading, it won't give the accurate reading until the two consecutive the two the two consecutive reading will be the same. Okay, I just try to mean that when the tachometer is giving 100 rpm is not the accurate result until it gets at the stable position. Like in the next step it will give 200 rpm. In the next step it may give 250 rpm. In the next step may it give 300 rpm. But in the next step it will give 100 300 rpm again. In the next 301. That means this 300 rpm is the accurate result because I have used this ladder system. Okay, you know, this rpm meter, I mean this tachometer has some internal problems or internal what should I say, internal mechanism which I have not mentioned in this video. But you know, if you are mature enough, you can take this problem by understanding this course only. Okay, so this is one problem I have told you. But another problem is that you have to put your hand in front of the fan with this tachometer for 5 seconds at least, because you know it will count 5 seconds cutting cuts, and then it will calculate. So this is the disadvantage obviously, and to reach to the actual value it will take a little bit time, maybe more than 1 minute on 1.5 minutes. So these are all the things, and in the next just thank you slide. But before just before leaving you guys, I just wanna tell you that this is the very much fast video and maybe my presentation is not so good, but any types of you know mistake is happened, then I obviously you guys takes it very much simply and with forgiving guys, right? And you know, with your support I am very much able, and without your support I am also able, but you know, little bit confidentless or just hopeless, or what should I say, or motivationless. Okay, so just I want to tell you guys, just keep motivating me by liking my videos, by sharing, by commenting, sharing your ideas, thoughts, opinions with me in these comment sections, or however you want. Okay, so yeah, this is all about for today. Thank you, bye, see you in the next video.